Hi, Craig here. Today I want to talk about the last part of the after treatment system. So we've talked about the DOC that was looking after the carbon monoxide. We talked about the PDF, particulate diesel filter, which was looking after the particulates in the first part of the after treatment system. We have to look at the history a little bit. So we had turbocharged engines that were creating lots of power and creating lots of heat. And that heat was making NOx basically, and it was also making carbon monoxide and particulate matter. So the EPA in 2002 said we have to reduce the PM and the NOx down to a certain level. They implemented a system, the tier system, and the tier system at this point, 2018, is tier 1, 2, 3, and 4. And we are at the tier 4 level on all engines on the highway and off as of 2015. So back to 2002, they just implemented EGR. And EGR, as the previous video would say, basically at a certain point when the vehicle was operating, we could put exhaust gas back into the intake manifold and reduce the temperature and reduce the NOx, which kind of created a problem. It created more carbon monoxide, more particulate matter. So we had to, in tier 2, we had to clean that up. So down here is tier 2 at 2006, where we were at 0.4, and I guess I should explain, this is measured in grams per horsepower per hour. So depending on the size of the engine, and you might have noticed the engines are getting smaller, which makes it easier to get different ratings for these grams per horsepower per hour. So as the tiers went from 1, 2, 3, and 4, the reductions in carbon monoxide, particulate matter, and NOx. I'm not going to talk about sulfur. We managed sulfur. We pulled the sulfur out of the fuel, and I think it's 0.0015% sulfur, which is very small, and it's manageable. It fixed the acid rain problem, or reduced it down to a point where it was, we could work with it. So back to tier 2 in 2006, there was particulate matter was 0.4 grams per horsepower per hour, and NOx was 4.5 grams per horsepower per hour. 2007, things changed. It started with the transport industry. The heavy machinery was usually about 2 to 3 years behind their regulations, so they got to go a little longer with making more pollutants. But 2 years later, basically, they had to follow. So I kind of based this on the first time it was implemented, which is in the transport industry. So 2006, tier 2, 0.4 particulate matter, grams per horsepower per hour, 4.5 NOx. 2007, EPA put out a new mandate, and we had to reduce that from 0.4 to 0.15, which was huge. And there's different bodies that will talk about percentages and stuff, which is really hard to do, because different people say it was a different percentage, 90%, 80%, but based on what is sometimes the question. So we just look at this as there's a huge reduction. So we can see that it's gone from 0.4 to 0.15 in the particulate matter, from 4.5 in the NOx down to 2.8. When we're talking about NOx, oxides of nitrogen, we talked about this earlier about how they're created in that hot combustion process, and we're creating oxides of nitrogen. And it's a family, that's why we say X. We don't know if we're talking about NO2 or NO, but those are the bad ones that cause greenhouse effects. NOx doesn't typically hurt people, except that it creates a greenhouse effect which damages our planet. And that's done through smog, and then the greenhouse effect starts to take place. So that is an important reduction. So tier 2 was here. Tier 3 is down here at 2.8 grams per horsepower per hour. And the DOC, as we were talking about, and the DPF started to clean that up. And they managed the carbon monoxide and the particulate matter while still having reduced the NOx through the EGR process. So things were good. However, tier 4 was coming. And down here we have tier 4. And everybody was worried about tier 4. And 2015, everything had to subscribe to Tier 4, and it did it. And this is how it did it. In 2015, we dropped to 0.01 particulate matter. Remember, we started at 0.4, and now we're at 0.01. Huge, sweeping changes in particulate matter. And again, we have a diesel particulate filter. They get my acronyms right. So diesel particulate filter is looking after the carbon monoxide, looking after the particulate matter, looking after a little bit of the NOx. The EGR system is looking after the NOx. And then in 2015, they said, let's reduce particulate matter from there to there. Huge changes. The DPF was doing its job. We're not going to talk about that one yet. The DOC was managing, and then we had to look after the NOx. So if we do more EGR into the intake manifold, we cool the combustion chamber down. Cooling the combustion chamber down causes more carbon monoxide and particulate matter. So it's a balance. We can get rid of one, we create a lot of the other. We get rid of the other, we create a lot of the first part. So back and forth. So we realized that turning up the heat or reducing the heat through the EGR process wasn't working. And keep in mind that our DPF has to be cleaned out. So regeneration had to take place, either forced or active regeneration, to keep up with this. So if we make an engine that runs too cold, it makes too much particulate matter and it plugs up the DPF. So we had to add another part, and that was called selective catalyst reduction. And selective catalyst reduction, basically, selective meaning it goes after NOx. And the NOx that I'm talking about mainly is NO2 and NO. So what we had to use something called DEF, which is diesel exhaust fluid, which is urea, a chemical that is turned into ammonia. So when it's injected into this mixing pipe, the temperature hydronizes it, and allows it to go into the SCR. And this is a catalytic process, so it takes less heat to crack these molecules and turn them into something better than what they are. So the hydrogenized ammonia sticks to the catalyst and sticks to the atoms of NO2 and NO, and basically turns them into water and nitrogen. In this process, it needed heat to do this process. There's temperature sensors all involved here. And when the temperature is right, and there's also a NOx sensor and a temperature sensor back here, being sent to the control unit, the DEF control unit down here, that is a computer that decides how much DEF and when the DEF is going to be injected. So the DEF is injected in there, reacts with the NOx, and turns it into nitrogen and water. Often too much urea was injected. If that was the case, it would neutralize the NOx and then be sent into the AMOX, which is an ammonia catalytic process that takes these ammonia particles and again turns them into H2O and nitrogen, which are safe for human beings. So this process, including the DEF, made it so that we could get rid of the NOx. So if the EGR is cooling the engine down and looking after the carbon monoxide and particulate matter, and then on the hills when it really needs to get going and that engine revs up and heats up again, looking for the power where the EGR is not being used, the NOx that is being produced at that point would be converted in the SCR. So this was the process. This brings us to 2015 at 0.01 grams per hour, I said it right, grams per hour, per horsepower per hour of particulate matter, and our SCR 0.2. Now 2006, 4.5 grams per horsepower per hour, now we're down to 0.2. Huge reductions, and that in 2018 now puts us into an area where it's meeting EPA standards. And all our transport vehicles, all our heavy equipment is meeting these requirements out there now because of this after-treatment system. Often it looks like a muffler. Modern ones, they've put all these units together in one. They used to be separated, but this is working. there is rumor that these catalytic processes that are happening in the DOC, the SCR, and the AMOX will change in the future, and the whole point is to get rid of DEF. DEF is about 3% mixed with the fuel, so the DEF tanks have to be filled. If not, there's a whole process where it derates the engine, and eventually you could stop the engine if you run out of DEF. So these are all the requirements to make sure that we're breathing clean air, and that's hopefully was helpful to you.